The silent evolution of modern aerial combat is defined not by the roar of engines or the heat of friction, but by the invisible architecture of the electromagnetic spectrum. To truly grasp the magnitude of what it means to cripple an entire naval or land-based radar network in seconds, one must first dismantle the illusion of the sky as an empty void. In reality, the atmosphere is a crowded, pulsating web of high-frequency energy, a digital ocean where sensors and emitters battle for dominance long before a single kinetic shot is fired. This unseen battlefield is where the fundamental principles of detection and survival have been rewritten. For decades, the primary objective of any military force was to see the enemy first. Radar was the ultimate eye, an undisputed sentinel that rendered the horizon transparent. However, the very nature of radar, the active emission of radio waves to illuminate a target, created a paradox that would eventually become its greatest vulnerability. To see, you must scream into the dark, and in doing so, you reveal your exact position, frequency, and intent to anyone equipped to listen. The transition from being the hunter to the hunted occurs at the speed of light. When we discuss the concept of a total blackout achieved with the press of a single button, we are looking at the culmination of 70 years of electronic warfare engineering. It is a sophisticated symphony of signal processing and strategic deception. The strategic shift began with the realization that an enemy's reliance on radar is their most profound weakness. If you can manipulate the data reaching their screens, you control their reality. This isn't merely about brute force jamming or drowning out a signal with white noise. It is about the surgical application of electromagnetic energy to deceive, bypass, and ultimately shut down the sensory nervous system of a modern military. The U.S. Navy's approach to this challenge evolved from the early days of simple radar warning receivers to the integrated multi-platform electronic attack suites we see today. The philosophy is simple yet devastating. If the enemy cannot find you, they cannot engage you, and if they cannot engage you, they have already lost the war of attrition. This mastery of the spectrum allows for a silent entry into highly contested environments, where the mere presence of specialized electronic warfare aircraft creates a protective bubble that renders traditional defenses obsolete. We are witnessing a paradigm where the most effective weapon is the one that never explodes, but instead leaves the opponent in a state of absolute sensory deprivation. This digital paralysis is not a fluke of technology, but a calculated exploitation of physics. By identifying the specific resonant frequencies and pulse repetition intervals of sophisticated radar arrays, naval aviators can deploy countermeasures that either mimic the radar's own signal to create ghost targets or simply lock the receiver into a loop of processing garbage data. When that single command is executed, it triggers a cascade of automated electronic responses that move faster than any human operator could possibly react. The result is a total systemic collapse of situational awareness. This capability has fundamentally changed the calculus of global power dynamics, turning the most expensive and advanced air defense networks into expensive scrap metal in the blink of an eye. The invisible war is won by those who can manipulate the fundamental forces of the spectrum to remain ghosts in the machine, ensuring that when the blackout comes, it is absolute, immediate, and irreversible. The technical reality of radar suppression hinges on the concept of electromagnetic transparency and the precise manipulation of the pulse Doppler effect. To understand the mechanics of a total blackout, one must dive into the intricate relationship between the transmitter and the receiver, a relationship that is fundamentally built on trust in physics. A radar system works by sending out a high-energy pulse and waiting for a fraction of that energy to bounce back. This return signal is incredibly weak, often compared to trying to see the reflection of a flashlight off a fly from a mile away. Because the receiver must be hypersensitive to catch these tiny echoes, it is also catastrophically vulnerable to any external energy that mimics its own frequency. This is the structural flaw that the U.S. Navy exploits with surgical precision. When an aircraft enters a contested zone, it is constantly scanning for the electronic fingerprint of the ground-based sensors. Every radar system has a unique signature, a specific frequency, a particular interval between pulses, and a distinct way of wobbling that frequency to avoid interference. Modern electronic attack platforms do not just blast noise, they act as high-speed digital mirrors. They capture the incoming radar pulse, digitize it, modify it, and beam it back to the source before the original echo can even return. This creates a digital hallucination. To the radar operator on the ground, the sky suddenly appears filled with hundreds of false targets, or perhaps nothing at all, as the jamming signal perfectly cancels out the real reflection. This is the one-button phenomenon in action, a transition from a clear tactical picture to a chaotic mess of ghost data. The sophistication of this process requires immense processing power, as these calculations must happen in nanoseconds. The goal is to overwhelm the signal-to-noise ratio of the enemy's equipment. If the noise becomes indistinguishable from the signal, the computer processors in the radar station reach a state of saturation. They cannot filter the truth from the lies, and the system effectively freezes. This isn't just about hiding a single jet. It is about creating a corridor of invisibility for an entire strike group. By synchronized emission, multiple aircraft can mesh their electronic signatures, creating a blanket of interference that covers thousands of square miles. This method of suppression has rendered traditional static defenses largely ineffective because it moves the battle from the physical realm of missiles and armor to the mathematical realm of algorithms and wave interference. The genius of the Navy's strategy lies in its adaptability. As radar systems move toward active electronically scanned arrays, which can jump between frequencies thousands of times per second, the suppression technology has kept pace by using machine learning to predict these jumps before they happen. The blackout is not merely a technical glitch, it is a forced obsolescence of the enemy's eyes. In this environment, the side that controls the spectrum controls the outcome of the engagement. The ability to render the most advanced tracking systems on Earth into blind, flickering screens in a matter of seconds remains the ultimate expression of modern technological superiority, proving that in the digital age, information dominance is the only currency that truly matters for survival in the high-stakes theater of aerial operations. The evolution of suppression tactics reached a critical turning point with the integration of the high-speed anti-radiation missile into the broader electronic attack architecture. This specific advancement shifted the dynamic from defensive posturing to proactive neutralization, creating a doctrine where the enemy's own sensors become the primary instrument of their downfall. The technical brilliance of an anti-radiation system lies in its passive seeker head, a highly sensitive broadband antenna that does not emit any energy of its own. Instead, it acts like a digital bloodhound, sniffing the air for the specific electromagnetic frequencies used by fire control radars. When a ground-based air defense system activates its tracking beam to lock onto a target, it essentially creates a continuous high-energy pathway leading directly back to its physical location. The missile follows this path with terrifying precision, turning the very signal intended to protect the airspace into a homing beacon. This creates a psychological and technical dilemma for the operator on the ground. To stay active is to invite a direct hit, but to shut down is to go blind and concede control of the skies. This interplay is the foundation of the modern suppression of enemy air defense's mission, where specialized pilots engage in a high-speed game of electronic chess. They utilize a combination of onboard receivers and advanced geolocation algorithms to map out the entire electronic order of battle in real time. By triangulating the source of emissions from multiple angles, the strike group can build a three-dimensional map of every active emitter within hundreds of miles. The speed at which this occurs is what allows for the instantaneous blackout effect. Modern processors can identify, categorize, and prioritize dozens of different radar types simultaneously, assigning specific countermeasures to each one without the need for manual intervention. This automation is the one-button reality that has redefined the frontline. The technical integration between the aircraft's electronic warfare suite and its kinetic payload ensures that the transition from detection to suppression is seamless. Furthermore, the development of solid-state electronics and gallium nitride power amplifiers has allowed these systems to generate immense amounts of focused energy across a massive range of frequencies. This means that even the most modern, frequency-hopping radars can no longer easily hide by switching channels. The suppression systems are now capable of sweeping the entire spectrum so rapidly that they can keep pace with the fastest digital logic on the ground. The result is an environment where the electromagnetic spectrum is no longer a neutral space, but a contested territory where victory is determined by the speed of signal processing and the sophistication of the software logic. By effectively severing the link between the enemy's sensors and their command and control network, the U.S. Navy ensures that the battlefield remains a one-sided window, where they can see everything while the opponent sees only static and shadows. This strategic dominance is not just about having better hardware, it is about a deeper understanding of the physics of information and the relentless pursuit of the absolute blackout. The tactical depth of achieving a total blackout extends beyond mere interference into the realm of cognitive electronic warfare and the manipulation of network-centric data streams. In this advanced stage of suppression, the objective is to target the collective intelligence of an entire integrated air defense system rather than focusing on isolated hardware components. Modern defense networks are designed to share information, meaning if one radar is jammed, another can theoretically pick up the slack. To counter this, the U.S. Navy utilizes a sophisticated method of distributed jamming, where multiple platforms, such as carrier-based electronic attack jets and unmanned aerial systems, work in perfect synchronization to create a seamless wall of electromagnetic distortion. This is achieved through high-speed data links that allow these platforms to share signal processing tasks in real time, effectively creating a massive virtual antenna array spanning miles of airspace. When the command is given, this network of systems doesn't just flood the air with noise. It executes a coordinated strike against the very logic gates of the enemy's command structure. By injecting false data packets into the communication lines between radar stations and their central command hubs, it is possible to make the entire network believe it is tracking thousands of non-existent objects, while the real aircraft move through a void of silence. This level of technical sophistication represents a shift from physical suppression to informational dominance. The complexity of these operations is hidden behind a streamlined user interface, where a single action by a pilot triggers thousands of automated subroutines. These subroutines analyze the incoming waveforms, determine the most efficient modulation to counter them, and allocate the necessary power levels to ensure the blackout is absolute. The physics of this process relies on the concept of constructive and destructive interference at a massive scale. By precisely timing the emission of waves, the suppression system can ensure that the enemy's radar receives a signal that is exactly out of phase with its own reflection, effectively nullifying the return signal before it even reaches the processing unit. This creates a zone of total darkness, where sensors simply report a null value. Furthermore, the advent of cognitive software means these systems can now learn from new, previously unseen radar signatures on the fly, adapting their suppression techniques within seconds of the first contact. This eliminates the traditional reliance on pre-programmed libraries and allows for a dynamic, evolving response to even the most secretive technology. The result is a tactical environment where the speed of thought is replaced by the speed of the processor, and where the outcome of an engagement is decided by which side has the more resilient digital architecture. This mastery over the electromagnetic environment ensures that the blackout is not just a temporary technical glitch, but a permanent strategic paralysis, leaving the opposition unable to coordinate, detect, or respond to any movement within the contested theater. The integration of artificial intelligence into this process ensures that the suppression remains persistent, even as the enemy attempts to reboot or switch to backup systems, maintaining the blackout for as long as the mission requires. The operational peak of modern electronic dominance is found in the transition from active interference to the era of total spectral control and the complete neutralization of enemy situational awareness. To achieve a state where an entire network is rendered useless in seconds, one must look at the integration of high-bandwidth digital radio frequency memory and its role in the modern cockpit. This technology allows for the capture of an incoming radar pulse in its entirety, which is then retransmitted with surgical alterations that deceive the logic of the most advanced signal processors on Earth. When we speak of a total blackout, we are discussing the systematic collapse of the enemy's ability to distinguish between reality and a digitally manufactured environment. This is not a matter of simply hiding, it is about taking control of the enemy's sensory input. The U.S. Navy has refined this capability to a point where a single platform can manage the electromagnetic signature of an entire strike group, making a dozen aircraft appear as a single bird or as a massive fleet moving in the opposite direction. The technical sophistication required to maintain this illusion is immense, relying on gallium nitride-based transmitters that can focus power with a level of precision that was once thought impossible. These systems operate on the principle that if you can dominate the first few nanoseconds of a radar's reception cycle, you can dictate everything that system sees for the rest of the engagement. This dominance is maintained through a process known as adaptive masking, where the suppression system constantly adjusts its output to match the changing environment, ensuring that no leakage occurs that could reveal the true position of the fleet. This level of control effectively severs the connection between the sensor and the operator. On the ground, the result is a total systemic failure that looks like a technical malfunction rather than an external attack. Screens flicker, data links drop, and automated systems report errors that cannot be cleared because the root cause is an invisible, shifting wave of energy that perfectly matches the frequency of the hardware it is disabling. This strategy has fundamentally changed the nature of deterrence. The ability to achieve a total blackout means that the very foundation of modern defense, the early warning system, is no longer a guarantee of safety. By the time the command is given and the first button is pressed, the battle for the spectrum is already over. The opposition is left in a state of absolute digital isolation, unable to communicate with their own units or coordinate a response. This is the ultimate expression of information age power, where the winner is the one who can most effectively silence the atmosphere and turn the lights out on the global stage of technical competition. The transition to this level of capability represents the most significant shift in aerial strategy since the invention of radar itself, proving that in the modern world, the most powerful force is the one that cannot be seen, heard, or measured by traditional means, leaving only a void where a sophisticated defense once stood. The resilience of this blackout is reinforced by continuous software updates and the integration of machine learning, which allows the system to predict how an enemy might attempt to counter the jamming, preemptively closing every possible electronic loophole before it can be exploited. This creates a cycle of absolute dominance where the blackout is not just a moment in time, but a sustained state of technical superiority that remains unchallenged throughout the duration of the mission. The ultimate horizon of electronic warfare lies in the complete synthesis of cyber operations and electromagnetic spectrum dominance, creating a future where the concept of a blackout is no longer just a tactical event, but a permanent strategic reality. As we look toward the next generation of aerial supremacy, the focus shifts from simply jamming a signal to the total penetration and rewriting of enemy digital infrastructure in real time. This is achieved through the integration of cognitive artificial intelligence that can interpret and exploit the software vulnerabilities of a radar system through the very waves it uses to scan the sky. In this environment, the single button press does not just emit noise. It sends a complex, coded payload that can bypass firewalls and enter the internal processing networks of integrated air defense systems. Once inside, this digital ghost can instruct the hardware to shut down, report false health statuses, or simply delete its own operational libraries. This convergence of hardware power and software intelligence means that the US Navy is no longer just fighting for the airspace, but for the fundamental integrity of the enemy's technological existence. The technical architecture behind this involves massive multifunction arrays that can simultaneously act as a radar, a high-speed data link, and a precision electronic attack tool. By utilizing wideband gap semiconductors, these systems can generate and steer beams with such agility that they can suppress multiple threats across a hemisphere of sky while remaining entirely undetectable to the systems they are neutralizing. The philosophy of the total blackout thus evolves into a state of permanent technical oversight. We are moving toward a world where sensors are designed to be self-silencing when they detect the presence of a superior electronic signature, a form of digital surrender that occurs before a single physical engagement. The strategic implications are profound, as the reliance on automated and networked defenses becomes a liability rather than an asset. The more connected a defense system is, the more pathways exist for an advanced electronic warfare platform to achieve a total systemic collapse. This is the culmination of decades of research into the physics of information and the psychology of automated systems. The blackout of the future is silent, absolute, and entirely irreversible by traditional means. It leaves the opponent in a pre-industrial state of situational awareness, while the strike group operates with godlike clarity. As these systems become more autonomous, the speed of this transition will move from seconds to milliseconds, effectively removing the human element from the initial phase of any engagement. The victory is won in the laboratories and the coding bays long before the aircraft ever leaves the carrier deck. This era of invisible dominance ensures that the spectrum remains a private domain, where the lights are only on for those who possess the keys to the digital kingdom. The total blackout is the final word in modern competition, a testament to the fact that in the age of high technology, the most effective way to win is to ensure the other side never even realizes the game has begun. The continuous evolution of these tactics means that the blackout is not a static capability, but a living, breathing digital organism that grows more sophisticated with every pulse of energy sent into the void, maintaining a state of absolute, unchallengeable silence across the global electromagnetic landscape.